Okay, we'll go ahead and get started. So today's workshop is software containers with Singularity. My name is Derek Strong. I'm a research computing associate here at the Center for Advanced Research Computing. If you want to log in to Discovery or Endeavor, Singularity is, of course, available. So if you want to follow along with some of the stuff here, feel free to do that. And also, if you have any questions throughout the workshop, feel free to type in the chat. I'll be keeping an eye on that. So just to sort of give a brief overview of the outline of the workshop. Basically, this is sort of intended as sort of an introduction to Singularity. So I won't go into too much detail about kind of the technical aspects of containers, but just focusing on sort of what containers are, why you might want to use one, how to get containers, either downloading them or building your own containers, and then how to run containers. So again, nothing too technical. Just kind of give a broader review. Ultimately, how you might use a container for your own applications. So first, what are software containers? So I guess in general, they're sort of like these isolated, portable software environments. So sometimes you'll see it kind of described as an operating system level virtualization. So another way to think about it is it basically provides a custom user space. So on CARC systems, basically what this would mean is instead of using the software modules that we have installed with the module commands, basically you'd have a container, and inside of that container, you would install whatever software that you would need to run your applications. And so basically, instead of using the module commands, you would use some, at least on CARC systems, you'd use the Singularity command, and then you'd run your stuff through your Singularity container. So let's say that container is going to contain whatever end application that you're using. Let's just take R for an example. So your container, you'd start with an operating system, then you'd install R. When you install R, that will install all of the various software dependencies that R requires. And then you can have that in a container and basically use that on any Linux system. So you may have heard of a virtual machine. Basically, the virtual machine, a container is similar to a virtual machine. However, a virtual machine is a little bit more sort of a heavy weight. So a container is going to actually have direct access to the kernel. So the kernel of the operating system is essentially that interface between the hardware and the software. So in contrast to a virtual machine, virtual machines do not have that direct access. And typically virtual machines, you're probably using it as kind of a graphical interface. Typically containers are going to be command line interface. And so virtual machines, because it doesn't have direct access to that kernel, there's going to be performance penalty with using a virtual machine. So with containers, because it does have direct access to the kernel, there isn't going to be like really any noticeable performance penalty using a container versus using a kind of a natively installed software on the host machine. So in this case, using the modules instead of the container, for example. So there's different types of container formats out there. On HPC systems, like the CARC clusters, basically the most common one that's used out there is Singularity, and that's the one that we support. I guess there's different reasons why it kind of ended up becoming the kind of most used format, but I won't get into that. And you may have heard of Docker. Docker is also a container format, but it's not designed to run on HPC systems. So typically HPC systems are shared systems. So you have a lot of users interacting and using the same environment. And the problem with Docker is that Docker actually requires root privileges in order to run containers. And so of course on a shared system, that's very problematic. Can't necessarily, give users root privileges. That could end badly. And so Singularity was developed as an alternative designed specifically for HPC systems. And so in contrast, Singularity does not require root privileges in order to run containers. So, okay, so why think about using Singularity containers for your research? So one reason might be because basically inside these containers, you can essentially install anything you want. And you don't really have to worry about any kind of security implications, anything like that. Because basically these containers are going to be isolated from the host system in that sense. And so of course we do maintain, this large software tree, the software modules on CARC systems. But that being said, we don't necessarily have everything. We don't necessarily have every single minor version, of every single software. And so sometimes it can be useful to have that kind of freedom to essentially install anything you want. Additionally, another big one is that once you build your containers, these are going to be portable and reproducible software environments. So essentially that means you build your container, you have a container file. Maybe you're collaborating with someone at another research university. They're using their HPC center. There's likely going to be some differences between our HPC center and theirs. So if you use a Singularity container, you can kind of be sure that you're both using kind of the same software stack essentially. And we'll look at it a little bit later, but basically, in order to build containers, you'll be using a definition file. And so the software environment is also reproducible in that sense, because you'll basically be creating this recipe. It's something that you can version control if you want, and it's just a plain text file. And so that can be super useful for reproducibility. So another thing to note, I don't think I said this, but basically Singularity is really only meant to be run on Linux systems. So again, there may be some limitations here, which I'll get to in a second. But it is designed specifically for Linux. There is actually a beta version of Singularity available for macOS. However, it's not up to date, and I guess it's the future of that beta is kind of uncertain. So I don't necessarily recommend that using it on macOS. Another reason you might want to use Singularity is that you can also containerize any workflows that you have. That might be useful in some instances. So more specifically, some use cases. So you can convert Docker container images to the Singularity format. And this is actually a common use case because a lot of times software that's out there is typically, at least right now, a lot of software is going to be, if there is a containerized version available, let's take an example, say something like PyTorch for machine learning. Typically, those are going to be distributed as Docker images. So at least right now, there's no sort of, PyTorch doesn't necessarily provide Singularity image formats. So in those cases, you can use Singularity to actually convert those Docker images to Singularity format, and then be able to run those on HPC systems. Additionally, another common use case is if you're using applications that need, say, older versions of software relative to what we have installed in the software module tree. On the other end, it might be cutting edge versions of software, maybe development versions of software that maybe are kind of a little bit experimental, not quite stable yet. And that's not something we necessarily want to support yet. You can also use containers for that. And also maybe there's something in between. Maybe you need a very specific version of a software that we don't have. So maybe we have, say, for example, we've got Python version 3.7.6. Maybe you need Python version 3.7.4 for some reason. That's not something that we're going to want to install on the software tree just because we have 3.7.6 available. And that fits most people's needs, at least for that version, for the 3.7 version. So having that extra minor version, that's not something that we're going to want to maintain. So that would be another use case of using a container in that example. Another use case is some software has very sort of complex dependencies. And so if you're able to bundle all of those complex sort of dependencies in one container image, it's going to be a lot easier for users to start using that software. So if you're an end user, if you're using one of these software that does have these kind of complex software dependencies, it can be a real headache to install stuff. So if the developer provides, a Singularity version of that, or maybe not Singularity, but maybe a Docker image that you convert to Singularity, that's going to be a lot easier to kind of get up and running, not have to worry about installation issues. Additionally, sometimes if you use proprietary software, typically on Linux systems, those are going to be distributed as binary files. And depending on how those binary files were created, they might not necessarily run on our systems because those binaries might need like certain libraries, for example. And so sometimes you might be able to use a container and install whatever library extra dependencies that might be needed inside of that container, and then therefore be able to use that proprietary software that way. So I'd say there's other use cases, but those are probably the most common ones. So yeah, so some limits of Singularity. So these aren't the hard limits. I'd say they're more soft limits. So these can be overcome. So one, as I mentioned, so Singularity is really meant for Linux systems. So another use case you might think of is, you might want to do some development work on your local computer, and then transfer your stuff to the HPC center. So if you're using a container, you might want to have you might want to use the container on your local computer as well as on the HPC center. Of course, most people don't use Linux laptops, things like that, any kind of Linux workstation. That can be a limit. I mean, you can get around that. You can install a virtual machine, install a Linux virtual machine, and then install Singularity inside of that and use Singularity that way. So it's definitely possible, but just adds a little bit of overhead. So there are, in terms of the portability, which is a good feature of Singularity, but there are some limits there. The portability does depend on a few factors. And so some of these would be the CPU architecture. Most HPC centers, I think, are x86 CPUs. But actually, I think some of the fastest supercomputers are actually based on the ARM architecture. So that can be an issue. I mean, that's also something that can be worked around. Basically, you'll just have to rebuild a container specifically for, say, the ARM architecture. Additionally, there could be problems with, say, binary formats, just compatibility issues, also with the kernel, with C libraries and other kind of APIs. Potentially, those kind of compatibility issues could be a problem for portability. Another thing to note, Singularity, right now, if you're logged in a cluster, the Singularity version we have installed is 3.6.1. And so Singularity, over time, the image format that it uses has changed, and so it's not always backward compatible. So for example, if you had a container image that was built under Singularity version 2, it's not likely to run under Singularity version 3. So sometimes that can be an issue. But again, if you're able to rebuild that image, you can just rebuild that image under Singularity version 3. Maybe you might have to make some minor changes to how it gets built. But again, that can be overcome. Another limitation in terms of building those images is you actually need root privileges to build Singularity containers. And I'll talk a little bit about that later. That's also something that you can overcome. But again, because you need a Linux system, and you might have to install virtual machine and stuff like that. But I'll talk a little bit about that later. And one thing to note on CARC systems, so Singularity is actually not installed as a module. It's just you can just enter the command directly, so you don't have to load a module or anything like that. Okay, so before I go too much farther, maybe to make this a little bit more concrete, I'll just kind of give a brief kind of example of ultimately where we're kind of going. How do you run a container, basically? What is it going to look like? Whoops. So I've got this container here that contains Julia and some Julia packages. So let's say if you're using Julia, so let's say if you're using the modules, if you're using the modules, you would do module load Julia, and then if you're running a Julia script, typically you just have Julia, and then whatever your script name is, script.jl. So similar setup for say R or Python. So if you wanted to run that Julia script through a container, basically what you would do, so I've got this container image here, julia.sif. You'd use the Singularity exec command. Then you'd pass it the container image file name that you want to run. And then you would just basically use the commands that you would normally use. So Julia script.jl in this example. So if I press enter, it's going to run that Julia script through the container. In this case, it just says, okay, hello world, and just prints that. Alternatively, maybe if I just wanted to say, check the version of Julia inside the container. Just run that, you can see, okay, Julia version 1.6. So if I just ran that by itself outside the container, it's not going to be able to do anything, right? Because there's no, I haven't loaded Julia, so it doesn't find Julia. So ultimately, that's going to, we'll talk more details in a bit, but basically that's when to make it more concrete, that's basically what's going to happen. Basically, you're just going to be running your commands through the software stack that's inside of that container image file. So the container image is basically, it's a single image file, as you see there. It's an executable file. Typically, it's going to have a .sif file extension. It's not strictly required. It basically just stands for Singularity image format. And inside of that Singularity image file, basically it's going to contain all of those software dependencies that you need to run your application. So one thing to note is that the image files are meant to be unchangeable. So basically, once you build it, you don't necessarily want to change it after that. If you do need to change it, if you run it, you realize maybe you forgot to install something. Basically, you just have to go and rebuild the container. And just a small note on kind of terminology, but technically speaking, there's the container image file, and then a container is kind of a running instance of that container image. So using that same file, you could have multiple containers based off of that container image running at the same time. And depending on what you have installed inside the container, the file size is going to sort of fluctuate. So this Julia container image I have here is only 185 megabytes. But container images can get pretty big. They can get up to multiple gigabytes. It's not necessarily an issue, but it can take up some space. Okay, so that was kind of a sort of brief overview of containers, kind of why you might use them. So getting container images, there's essentially two different ways you can do it. If there's already existing images out there that you can use the Singularity pool command and basically download those. Sometimes maybe a software developer, maybe they're just simply hosting a container image file on their website, maybe a GitHub repo, for example. You just have to basically just download that and you can start using it. Alternatively, if you need a custom container image, you just have to build your own image. And so I'll go through both of those examples in turn here. So pulling existing container images, of course, is going to be the easier approach. So if you can search and find container image that works for you, that's going to be easy. So the main command for pooling images, first, so there's different container repositories out there for Singularity. So the two main ones you'll probably end up using would be the Singularity library and Docker Hub, if you're converting from Docker to Singularity. So if we go to the Singularity library website here, Scilabs is kind of the commercial company behind developing Singularity. And so basically this is just kind of a repository that they host. And you can kind of go through here and search and kind of search through, kind of find, if it exists, container images that might be out there. So let's just say if we search for, say, Alpine, then you can see a bunch of different Alpine Linux container images that might be out there. So just to give a quick example, let's say we just want a kind of a sort of very basic Ubuntu container image. So for this, for using the library, the command is going to be singularity pool, and then library, and then colon and // and then whatever the name of the container is, and then a version. So in this case, the name is going to be Ubuntu, and I just want to pull the latest version of Ubuntu. So it's just going to be Ubuntu colon latest. So if I hit enter, it'll start, well, okay, so I'll talk about this later, but there are, when you start pulling images, Singularity will actually cache those images, meaning it will store a copy of those images in your home folder. So let me clear that out. I think it's Singularity cache clean. Yeah. If I go re-enter that command, whoops, already got one. Let me remove that one. Okay, so now pretty simple. This one's relatively small size. So it'll tell you, okay, downloading library image, gives you a little progress bar there, and then it'll take a few seconds in this case. So in this example, it'll automatically name it. So in this case, it's named Ubuntu _latest.sif. If you want to give it a specific name, you can do Singularity pool, and then after the pool, you can name it whatever you want. So let's just, maybe we want to make it shorter. So we just call it ubuntu.sif. In this case, again, it's using the cached image. So basically, it's just copying from the cache. And so there you can see it changed the name to ubuntu.sif. So if you were using Docker Hub instead, so it's going to be a similar. So it's basically container repository. So let's say if we want to search, I guess just say search for an Alpine Linux image. Here's the Alpine repository. You can kind of, there's a bunch of different versions. Let's just, you can kind of identify which one. So in this example I have here, the only difference here is instead of that library, you're using Docker instead. So Singularity pool Docker, and then the name of the image, and then the version. So if I did that, in this case, it's going to automatically convert it from the Docker format to the SIF format. So you can see that there in the first line. In this case, it's this image is relatively small, so it just takes a second to download and convert. I would basically just give you some progress there. It says converting, starting build, and so on. So if I check it again, there you can see Alpine latest.sif. And again, same thing. So if you wanted to name it, give it a specific name, you just add it after that pool. So again, it cached that, so it just copied that cache and then changed the name. So again, so that's relatively easy. So if you weren't using one of these repositories, if you were just downloading it from the web, basically, you could use any of those download tools just to download it. So either say wget, whatever the URL to that image file is, or maybe a RIA2C, for example, and then the URL. And then it'll just download it. So relatively simple. So if you want to build your own container image, which in a lot of cases is probably what we want to do, it does require a little bit more setup. So again, so as I said before, if you actually want to build container images, the command is Singularity build. But in order to use that command, you actually have to have root privileges. And so on CARC systems, of course, we don't give users root privileges. So you'll have to end up building outside of CARC systems and then transferring the file to your, say, your project directory. But again, since you need a Linux system, that also adds a little bit of overhead. So there's basically two different approaches you could do, you could use. So the one I'd recommend to make it as easy as possible is you can use this cloud-based Singularity remote builder. And basically, this is just a web interface. So this basically allows you, so you don't have to worry about installing a virtual machine. So that's going to be the alternative. So if you wanted to build it on your local computer, you'd have to install some kind of virtual machine application. So I'd recommend something like multipass. Basically, this is you install the VM, you'd start a Linux virtual machine, and then inside that virtual machine, you'd install Singularity, and then you'd use Singularity build to build the container. So that's, I mean, it's not necessarily difficult. It just adds a little bit of overhead. And since this cloud builder exists, just, might as well use that. It's a little bit easier. So the general workflow again, so basically you'll build externally. You'll use what's called a definition file, which is basically the recipe for how you're building the container image. Once it builds successfully, then you'll want to transfer that image file to one of your directories on CARC systems. And again, you can transfer it in a few different ways. If you're building it locally, you can just use one of the GUI SFTP apps. If it's a big file, maybe use Globus, any of those command line tools. With the Singularity remote builder, we can actually use a Singularity pool command, which I'll demonstrate in a little bit. And then, but once you get it in one of your directories, then you can just run it. And so that'll be the basic workflow. So when you're building container image, basically you'll have this definition file. You'll create a definition file. And this definition file is going to have a bunch of different sections in terms of its structure. But first, you're going to start with essentially a base operating system that you want to use. So any kind of Linux OS, could be Ubuntu, could be CentOS, it doesn't matter. Alternatively, if you've actually identified a container image that's out there, and maybe it almost meets your needs, but maybe you need to modify one or two things to that container image, you can also actually start with that container image and then build on top of it. So that's also a possibility. And then so basically then you'll start with one of those two, and then you'll install software, any additional software you need, add any files, and so on. So conceptually, that's kind of what's happening. So just to give it an example of definition file, well, at least in terms of the structure of the definition file, it's going to look something like this. So basically, you'll have a header, and then you'll have some sections below the header. And so the headers, you'll probably have these two sections, a bootstrap and from. And so the bootstrap, basically, it'll kind of be similar to what we just saw with that Singularity pool command. So the bootstrap will be either, basically you're pulling from the Singularity library or maybe Docker Hub. Basically, because you're starting with some kind of base Linux operating system, basically what it does is it just pulls that kind of minimal operating system container that we just downloaded. It basically starts with that and then builds on top of that. And so that's what these sections do here below the header. And so technically, all of these are technically optional sections. You don't necessarily need all of these. But the one you'll primarily be using is the post section. So that's the section where you'll include all of the commands where you're going to be installing your software, libraries, maybe setting up configuration files, things like that. The other sections, there's the file section. You can actually copy files into the container from the host. So if you had some kind of files in your project system that you wanted to actually copy into the container, you could do that with the file section. And basically the syntax is you just have the path to the source file on the host, and then you specify inside the container whatever file path. And so that's one thing to note here. Inside the container, there's actually a separate file system inside of the container. And so I'll look at that more concretely in a bit, but just something to keep in mind. So additionally, there's also the test section. So this is a section you can use if you want to run some commands to basically validate the build process. So basically, maybe if you installed Python or something, you might want to run a command that's like, Python -- version, just to verify that it's the correct version installed. There's also an environment section. So if you need to define any kind of shell environment variables at runtime, you can do that in that section. You can also have a start script. You can also have a run script. Start script you probably won't use. You basically use that if you're using the Singularity instance start command, which probably won't use. But the run script is something you might use. This is basically, you'll define a script here, and you can basically run, if you use the Singularity run command, it'll basically run through the script when you execute that command. And we'll take a look at that in a second here. And so this is good. That section is going to be useful if you're interested in developing sort of containerized workflows. That's where you'd want to include some kind of a workflow kind of script that you can kind of pass in, say, data files or parameters and things like that to the containerized run script. Additionally, you can also have a label section, and basically that's just some metadata. And so those you would enter as name value pairs. So maybe like an author, creation date, something like that. And then last, there's a help section. So basically some additional metadata basically just describes the container and maybe what its intended use is for. Okay, so let's give a more concrete example. So this example here is basically that Julia container image that I have there. This is basically the definition file that I used to build it. Oops. So looking first at the header, so the bootstrap. So basically I decided, okay, I'm going to pull this existing kind of base OS container. In this case, Ubuntu version 20.04. Pull that from the Singularity library, start with that, and then build on top of that base operating system container. So then I have my post section. So this is where I'm going to install, in this case, I'm installing Julia and some Julia packages. So depending on what base container sort of OS that you're starting with, you might actually have to install some base tools. So in this case, I actually had to install wget. And again, depending on what base OS you're using, the install commands might be different. So in this case, using Ubuntu, with Ubuntu, you use the apt package manager to install packages. And so here I'm using, apt-get update to make any updates to the base operating system. Then after that, I'm going to install wget. Once wget installs, then I'm going to install Julia. So in this case, Julia is actually pretty easy to install. Julia just distributes binaries for Linux. So you just download that Linux binary. In this case, it's downloaded as a tar file. So you just extract it. And in this case, depending on how you want to set up the software in terms of the software paths, you can create symbolic links, set up whatever paths you however you want to set it up. In this case, I created a symbolic link. And again, as I mentioned, there's a separate file system inside the container. So in this case, I changed my directory to user local, downloaded it in that directory. And then I created a symlink from that downloaded binary file, and then added that symlink to the user bin space. So basically that way, that user bin directory, that's going to automatically be on your path inside the container. And so that way you can just use the Julia command directly. And in this case, since I downloaded that tar file, basically, if you wanna keep your container image file to a minimum, sometimes it can be a good idea just to go ahead and remove any files that you don't need. In this case, I extracted that Julia binary. That's all I need. So I'll just go ahead and remove the tar file that I downloaded. So then, okay, so I unpacked Julia. Now I have access to Julia. It's on the path. Now I want to add some Julia packages. So in this case, this is the command that I would use. So in this case, just basically adding some statistical packages. The next section, this isn't really required. This is more for metadata. But if you wanted to basically store the date that the container was created, just to kind of have a record, you can include these lines here. Okay, so that's a relatively simple example. So just basically downloading Julia, adding some Julia packages so that I can have a containerized version of Julia for my specific project that I need. So after that post section, so I've included some other sections here. Again, these are optional, but I included a test section. So, okay, I want to just test, make sure Julia installed okay. So I just include Julia -- version just to make sure. Just included some basic environment variable there. Then for run script, in this case, nothing fancy. If you use the Singularity run command on this container, basically it just starts up an interactive Julia session. And so really that's just a shortcut. I'll show it in a minute, but that's just kind of a shortcut instead of using the Singularity shell command. And then I just included a short help description. This container is based on Ubuntu 20.04 with Julia 1.6.0 installed along with some other packages. So, okay, so let's take this definition file. Let's go to the remote builder and let's actually build this. So let's see. So when you first, if you go to this URL, if you want cloud.silos.io/home, you'll see Singularity Container Services. You'll see here the cloud library that we looked at. And then you'll see the create remote builder. So that's what you want to click on. Before you can actually start building, you actually have to sign in. So there's 4 different options here. Basically, you can connect this to either your Google account, your GitHub or GitLab account, or your Microsoft account. In my case, I've got it set up with my GitHub account. So I just signed in with GitHub. I'm already logged into GitHub, so it just automatically logs me in there. So basically what's going to happen here is you basically you enter your definition file here into this section. So what I would recommend, so you can type directly into here, but what I would recommend is actually create your definition file locally, say in some kind of text editor. And once you're done with it, then just copy it and paste it in here. That way you have a record. You have it stored on your local computer. In case something goes wrong, with this build process, it's possible you might lose what you've typed in here. So just to be safe, I'd recommend, create the definition file with a text editor on your local computer and just copy and paste it in. So I think I can just copy and paste it here. Oops, might get cut off here. So, okay, so if I just copy and paste that, so one thing it does tell you, it does validate your definition file. So as long as there's a green check right there, it means everything looks good in terms of the syntax. So basically, once you've got that copied in, there's some other options here. So basically, when you log in, you can kind of specify where the image gets stored. The default's fine. I don't necessarily recommend changing that. So just keep that default image. Then you'll hit the build section. Then it'll start building and it'll give you a log. So this one shouldn't take too long. As you can see here, it started running. So you can see that apt-get update command ran. It installed wget, some dependencies for that. Looks like maybe there's some warning messages here, nothing fatal. Downloaded the Julia file, unpacked it, now it's installing the Julia packages. Even though I was only installing, say, 3 packages, or 4 packages, it has to install these other dependency packages. So now it's just kind of going through installing all those. It shouldn't take too long, but eventually, basically your build's it's either gonna be a success or it's gonna be a failure. So if it's a failure, basically you'll have to look at this log here. It'll give you, whatever the failure is, there'll be some kind of error message here. And then you'll just have to go back to your definition file, make some changes, and try again. In this case, it should be a success. I tried it earlier, so it should work. So in this case, if you do have a test, section there, it'll also run it when it builds. So in this case, I just had that Julia Desk version. So here, Julia version 1.60, that's the one I wanted. So that seems like a success. And now it's just kind of wrapping up. Everything ran, now it's creating the image file. And if you wanted, so this was I guess a relatively simple one. This log file is not too long. If you have, a more complicated definition file, these log files can get pretty big. So you can always download the log file if you want. I don't know. I'm not sure if there's a record of this is actually kept around if you actually go to another page. I'm not sure. But ultimately, so it's still creating the image, but basically this running here at the top, this will change to a success. There you go. So now it's green, success. If it was a failure, it'd be red and it'd say failure. But in this case, okay, it's a success. So then you want to go to basically your personal container library. So if you click on sort of username there, then you go to My Containers. So one thing to note, so this is a free service, but there is a limit to how much you can store. So I guess in this case, I thought it was a 10 gigabytes, so maybe they've increased it. It looks like 11.26 gigabytes storage quota, which is, it's pretty good, pretty generous, unless you're building like really big images. That should be plenty of space. If you need, you can always delete your image files after you say transferred them to save space. But here at the bottom, you'll see we saved it in this default image location. So if you click on, say, image in this case, you'll see there's 2 different versions. One of these I installed earlier, and then I guess this is the latest one is the one I just built. So in this case, you can see here, there's some buttons here. So you can download or show pool command. I think if I download it, I think it's just through the browser, you can just download the file if you wanted. But if you're transferring this to CARC systems, you want to use the Singularity pool command. So if you click on show pool command, it'll give you 2 examples that you can use. Let's just use the first one, Singularity pool. And I think in this case, I might have to update my access tokens, but let's see if this works. Let's see. So if I copy that over, before I pull it, so you notice there's an extra option here, --arch for architecture. So in this case, AMD 64. So that's what we want. AMD 64 is also known as x86, so that's fine. But I want to, let's get another name. Since I already have a julia.sif, let's call it julia2.sif. And then hit enter. And you can see it starts downloading the library image. Doesn't take too long. In this case, there's some warning messages. It just says, no signature found. I didn't create like a verification signature in there, so not a big deal. But that is something you can do if you want. So if I check my directory again, now I've got that julia2.sf file. So again, that's going to be the easiest approach. So if you use the remote builder, you don't have to worry about setting up a virtual machine. You can just copy your definition file over, build it, and then pull it directly into one of your directories. And in that way, you also don't have to worry about maybe your upload speeds aren't great at your location. So if you're creating a big container image, being able to download that directly from the cloud into one of your directories is also nice as well. So that's the basic setup. So that's using the sort of web interface with the remote builder. You can actually also use the command line, so you don't actually have to log in there. If you wanted to build it remotely, so I also have the definition file here. This one might be slightly different actually, but so yeah, so this one doesn't install Julia package, but okay, pretty similar, using an older version of Julia. Let's say, so I have that definition file in my directory on CARC systems. Let's say I just wanted to build that with the remote builder. So in this case, you'd use the Singularity build command, but you'd use this remote option. So again, normally if you're using the Singularity build command, you would need root privileges. So you'd have to use sudo Singularity build. But again, you're not gonna be able to do that on CARC systems. So in this case, you can just build it remotely, which basically says, I have this definition file here, copy it to the remote builder, build it, and then transfer it back to my directory. So I think it's just Singularity build -- remote and then the name of your definition file. In this case, I don't think it's going to work because I have to update my access token. Oops, looks like I have the syntax wrong. Let's see. So if you wanted to look at the help options, you can do Singularity build and then help. Singularity build remote. Let's see. Image path and build check. Okay, so I forgot to name it basically. So basically, let's just name this one Julia test.sf. So now it didn't work because I have to update my access token. So basically the way the remote builder works, if you want to build remotely, you do have to log in, but you get this access token here. If you click on access tokens, basically they expire every 30 days. So basically you just have to, every 30 days, if you just create a new access token, give it a label, just say CARC or discovery, something like that. It'll give you this access token here. So you just copy and paste that. Go back to your terminal. Use the Singularity remote login command. So if you do that, hit enter. Then you just paste in that API key and hit enter. If it's a success, it'll just say API key verified. Okay, so now I have a new API key. So now if I do that remote build again, it should work. And so basically it'll start doing that build log in your terminal essentially. So the same thing that we saw in the web interface, but now it's just in your terminal. And so to be clear, it's not actually running on CARC systems, it's running remotely, but it's just basically transferring that log back to your terminal. So this one took a little bit shorter because I'm not installing the Julia packages. So it's creating that CIF file remotely. And then once it ends, it'll just transfer it into my directory. So shouldn't take too long. So yeah, so again, this access token expires every 30 days. But if it does expire, basically you'll just get that warning message and you'll just have to go back and redo the access token. Okay, so now it's build it, now it's transferring it. And okay, so now it's build complete. So if I check my directory again, Okay, now I've got this julia-test.sf file. And so again, if there was some kind of issue with the definition file, again, you'd get a failure message. And then you just have to go back, modify your definition file, and try again. Okay, so now we have some Singularity image files that we can start to use. So in terms of running containers, there's essentially 3 main commands that you'll use depending on how you want to use the container. It's either going to be Singularity shell, if you want to get an interactive shell within the container. Or you could use the Singularity exec command. And so that's basically going to be, you're basically executing commands in batch mode through the container. Or you can use Singularity run if you've set up that sort of predefined run script in the container. Either that's a run script that you built when you built your container, or if you're using a pre-existing container that has a run script, you'd use Singularity run. And so we'll look at all 3 of these just to give a demo here. And so again, so one thing to note is so this, when you're running the containers, it's a Linux process, just like any other process. You're just using that different software environment that's inside the container. So that's the only thing that's going to be different. So let's start with the shell. So if we do Singularity shell, and then let's do this, I guess the Julia 2 one that we made here. So basically you just do Singularity shell and then the name of the container image here. So julia2.saf. So when you're doing the shell, it just changes your shell prompt here. You'll see it changes the Singularity. And so this lets you know that now, okay, now the container is running and now you can interact with it with the command line interface. So let's take a look at the file system. Basically, I mentioned before that there's basically there's another root file system within the container. So if we do ls-l and then just a / this is going to print the file system inside the container. So again, this is Ubuntu. So this is another Linux operating system. So the CR cluster runs CentOS, but it's fine. We can run Ubuntu. It's fine. Again, it's a container. But there'll be some commonalities here. So you'll have like a bin directory, all these kind of common Linux directories, dev, etc, home, and so on. So one thing to note about when you're running containers, there's actually some directories that are going to be automatically bind mounted to the container. So you can see here, there's a home directory, but then I also have my home1 directory. So the home directory is the home directory within the container. And then it also automatically, in this case, since on CARC systems, your home folders are in the home1 directory, it's also going to bind mount the home1 and then whatever your username is. So if I just listed the home directory, for example, there's actually nothing in that one. But if I did home1, you'll see that, okay, that's just my home directory on CARC systems. So all that stuff that I have in my home directory. And so sometimes you'll want that. You'll want that by default, but sometimes you won't want that home directory to be bind mounted. And there's a way to turn that off. And I'll show that a little bit later. It's basically just an extra option that you pass in to the Singularity command. So the other directories that are automatically bind mounted is the temp directory. So that's the local temp directory will also be automatically bind mounted to the container. In this case, you also see my scratch directory here is bind mounted to the container. That's not actually automatically bind mounted, but I have an environment variable set up that, well, for me, I've set it up to automatically bind mount it. And I'll talk about that a little bit later as well. So that is one thing to keep in mind. You can actually bind mount containers on the host system. So any of the directories that you have access to, you can bind mount those to the container. And sometimes, you might want to do that because you might have files in in your Scratch or project directories that you want to include inside of the container. You do want to be careful with that. Sometimes that can cause issues with the interactions with kind of the software inside the container. So sometimes you might have to set up like very specific directories that you want to bind mount. So yeah, so if you're in the shell inside the container, you can do similar Linux commands, pwd. I'm not sure what, if we check this bin directory, what stuff's installed. Probably be basic stuff. So if you do which, I think we installed wget. So we do which wget, you see, okay, user bin wget, all that stuff. So if you do which Julia, this is the Julia I installed. So that's the user bin Julia that I made. Julia-version. So again, this was the Julia 1.6.0. And then if you want to use Julia interactively, in this case, Julia, just enter Julia. It opens up an interactive Julia session. And then you can do your interactive work within the container if you want to do some interactive work. And so that's basically it, I guess, for the shell. And if you're building containers, maybe you're doing those commands where maybe you want to add files to the container, install stuff in a specific directory within the container. You might use this Singularity shell, this interactive mode, to kind of go into that file system and kind of confirm that stuff is where it should be. So that would be the other use for it. And if you want to exit the container, you just hit exit, and then it exits the container, brings you back to it's just outside the system, outside the container, back to the directory. So the next command, Singularity exec. So basically this will be kind of like the batch mode, essentially. This will probably be the one you'll use most often. Similar setup, so Singularity exec, the name of the container. So it's julia2.sf. And then again, as I showed earlier, this is where you will basically type the commands that you would normally type. So in this case, let's just run that Julia version command again. So it takes that command, runs it through the container. So again, Julia version 1.6. And again, if I just ran that outside the container, I don't have Julia loaded, so it's not going to find it. So I've got a script here, again, that hello world script. So if I just run that, it's going to take that script and then run it through the container. So again, relatively simple. As long as you have that container image set up, that's probably where most of the effort is going to come from, just getting your container set up how you want it to get set up, make sure everything installed correctly. And then apart from that, you're just running the commands that you would normally use as if you were on using the software modules or on your local computer using the command line. So as I mentioned, so I mentioned that not bind mounting your home directory, for example. In that case, you can pass different options in. There's a bunch of different options. So if you didn't want to bind mount your home directory, you'd add this no home option. In this case, it doesn't affect. Oops, I guess it did affect my Julia script. So sometimes you'll want to include this no home. I've seen issues with this. If you're using, say, Julia or Python modules or R packages, things like that, if you're using the software modules and installing those into your CARC directories, because the container automatically bind mounts your home directory, it's possible it's possible that the container will try to use those packages that you've actually installed using the software module trees. And so sometimes that can cause issues because it's not compatible. It might be a different R version or something like that. So that might be one of the reasons you would use this no home option. In this case, I'm not sure what's happening there. I guess it caused some issue. Maybe my home directory needs to be bind mounted. But there's a lot of other options. So if you do Singularity exec and then help, it'll open up the help page. Whoops, typo. No typo. Basically, it'll list all these options that you can use. Give you some more information, and I'll take a look at some of these two other ones that you'll use in a second here. But first, let's look at the Singularity run command. So with this Julia container that I created, I just created that simple run script, right, which basically just opens an interactive Julia session. So I could use the Singularity shell and then type in Julia and open up interactive Julia session. But just for convenience, I just set it up as a run script. So if I do Singularity run and then julia.sif or Julia2, basically it'll open the container and then automatically open Julia. So this is, that's just kind of a simple example, just a convenience basically. But typically if you're doing run scripts, it'll be something more complicated. It'll be some kind of like workflow probably. So that's where you'd use the Singularity run command. It's basically the Singularity exec command, but it's basically just, instead of running one command, you basically have this predefined script and you can pass in, maybe you're just using the same script and you want to, pass in different data files to the same script, different model parameters, things like that. You can set up the run script in that way. So yeah, so going back to those options, there is this option -- clean env, so clean environment. So the other thing about Singularity, when you run Singularity containers, it's actually automatically also going to feed in all of the shell environment variables that are set. It's going to pass all of those into the container automatically by default. And so that can actually be problematic on HPC systems like ours that use these software modules. So if you have modules loaded, basically what's going to happen is basically it can kind of mess up the container. Might try to use like a different, maybe you have Julia, you want to use the Julia version that you have installed the container, but maybe you've loaded the Julia module. It might try to use the actual module version of Julia instead of the container version. So that can cause issues and compatibility issues. And so basically we always recommend using this clean env option. And basically that establishes a clean shell environment inside of your container. And that way it helps to avoid those issues. And I actually don't know why. It feels to me like that should be the default option. That should be on by default. And maybe there's a reason why it's not on by default. But definitely recommend including that one. So we just saw the no home one. So sometimes you might want to use that one. And then another common one you might want to use is this bind option. And so this is where if you want to bind mount directories to the container, you can just pass in those directories. So if I do Singularity shell, let's just say add this clean env option, and then we can pass in, let's say I want to bind mount my scratch2 directory. You just do -- bind and then the path. And I think if you only include the path, it'll basically duplicate that same path inside the container. But you can also specify a different path as well. But let's do this one first. So if we do that, and then we do that julia2.sf again, okay, open up the shell, do else command. Oops. So now you can see, okay, that my scratch2 folder was bind mounted. So now I can interact with any files I might have in my scratch2 directory within the container. And so just to verify, just type it out. And you can see I got some files in there. So I think another way you can do this is if you don't want to actually duplicate that directory path inside the container, you can specify whatever the path is inside the container. So if you wanted to do, say, if you wanted to bind mount that to a different location, let's say you wanted to put it in that home folder, let's say home/scratch2, for example. I might need a colon here. let's see. I think you have to do the source, basically the source directory, then a colon. Yeah, do a colon and then the directory inside the container. So now if I check that file system again, so you don't see the scratch2 here again, but now if we check that home directory, now that's where scratch2 is. And then now you can see my files inside that directory now within that different directory path within the container. So sometimes you might want to do that. Again, just kind of depends on how you want to organize the files inside your container. Okay, so that's sort of an overview of running containers. There's sort of two special cases. There were things you might have to do a little extra to get working correctly. So those two special cases would be MPI and GPUs, if you're using GPUs. So if you want to use containers with MPI programs, there's different ways you can do it. There's basically two approaches. One's called the hybrid approach, the other is the mount approach. And I guess there's sort of pros and cons for each. I haven't had a lot of time to actually go through and test these MPI jobs, but if you go to the official docs, they kind of run through these different options, tell you a little bit about setting it up, the pros and cons, and kind of what you need to do to use your Singularity container with MPI programs. I think the hybrid approach, basically, if you're building a container, basically you have to match the versions of MPI inside the container, match those to the versions of MPI we have installed in our module system. And then I think the bind approach is basically, you're basically just using that bind option, you're bind mounting those directory paths of the MPI versions we have installed natively through the software module system. You're basically just bind mounting those to the containers and using MPI that way. And there might be, depending on how you're using MPI, you might use one or the other. But I'd recommend just, if you are doing that, read through this documentation page to get a better idea of how you might use it. But ultimately, it'll be, in terms of running MPI programs, it'll be pretty similar. MPI run -n, the number of ranks, and then Singularity exec, and then your container, and then the path to your MPI program. And so typically, if you're using a container, you want to compile that MPI program within the container. So that's something you can either do. You probably want to do that in the definition file, for example. But yes, I won't go into too much detail on how to do that. So the other case would be using GPUs. It's kind of a similar thing. If you want to use containers on GPUs, there's also kind of two approaches. Traditionally, what you would do is you would, inside of your container, you would also install, you'd have to match basically the versions of the drivers and libraries that we have installed natively on CARC systems. So you'd install both the NVIDIA driver as well as whatever CUDA library, for example, that you're using. So that's what you did traditionally. Recently, they've added this sort of option to the Singularity commands, --nv. And I guess the idea there is that it basically allows you to kind of skip having to install the correct versions, and it basically helps you, I guess, automatically kind of detect the drivers and libraries that are installed on the host and basically pass those into the container. I think right now it's an experimental option. It's relatively new, so it might not be super robust, but you can also just try using the --nv option. And depending on, I guess, how you're using the GPU, that might work for you. If you do need to figure out what the versions are, we recently updated the GPU, the NVIDIA drivers. I believe now it's the version 460, but if you do need to kind of check those, you can run the NVIDIA -smi command on GPU nodes, and that'll give you the driver version and the latest version of CUDA that you could run on it. And so again, if you basically just, depending on what kind of container you're working with. If you're building your own, whatever, you get your container image. And this example may be a common example to be using TensorFlow on GPUs. TensorFlow has some Docker container images. You could basically convert those to Singularity format, and then just use Singularity run, for example, --nv, and then the name of that container file. And then that's how, I guess, well, actually, what I should have added here is also that clean env option. There have been issues with running containers on GPUs, and you'll definitely want to use that clean env option if you're running on GPUs. I'll update the slides later with that clean env option. So Singularity also has some different environment variables that you can use, basically just to kind of add some convenience. So there's a bunch of them, but here's a few that I'd recommend. Now, if you are using Singularity, as you saw earlier, there was this cache directory. So again, if you're pulling in containers, downloading containers, Singularity is actually going to cache those in your home directory by default. And so cache meaning it's going to copy those in a hidden directory inside your home directory. And so that way, anytime that you want to re-download that file, instead of actually downloading it, it recognizes that you've already downloaded it. So it basically just copies it. However, since it's automatically in your home directory, these container images can be quite large. And so that can take up space in your home directory. You do have that 100 gigabyte quota. But you can set this Singularity cache direct environment variable, and you can change that to, say, one of your Scratch directories. And then that way, it won't cache those in your home directory. It'll cache those in your Scratch directory. So in this case, the example would be export Singularity _ cache direct equals, and then the path to wherever you'd want to store the cache. I'd recommend this setup, so scratch/username/.singularity. Additionally, another one you might want to set is temp direct. Sometimes Singularity will use the local temp directory on login nodes, say when you're pulling in files or running files. So either on the login node or on compute nodes. And those temp directories are going to be limited. So there's limited space there. And so you might hit a limit. And so that could cause the run to fail, basically. So I'd also recommend setting this temp direct, basically create one inside that hidden Singularity file. In this case, hidden Singularity directory that you set up in your Scratch directory, basically just create an explicit temp directory and just set it to that. And then that way you won't have to have any issues with hitting those temporary directory limits. And so to set these automatically every time you log in, basically you'd add these two commands to your bash.rc file. The other common one you might use if you are binding paths to your containers a lot, you can also use the Singularity bind variable. Instead of using that -- bind option that we saw earlier with the containers, you can use this. You can set the shell variable, and that way you don't have to type out that -- bind all the time. And then you can, if you also add that to your bash.rc, basically that will automatically set that up every time you log in. And then whenever you use Singularity commands, it'll automatically bind mount those directories to your containers. So again, you might not necessarily want to put that in your bash.rc. Only do that if you're always, wanting to bind mount those directories into your container. So as we saw, so if you do need Singularity help, basically at the command line, you just enter Singularity help. And there's kind of a main help page, and then there's separate help pages for each of the Singularity commands. So Singularity help will give you some information. If you wanted some help with the pool command, for example, Singularity pool -- help, give you more specific help for that command. But of course, there's also online documentation. So if you go to the official docs, it's pretty thorough. So some things are missing, some things are unclear in here, but it's always being updated. But this will go into a lot more detail in those help files at the command line. So if you do want to look into Singularity a bit more, I'd recommend going to this user guide page and doing this quick start. This will kind of run you through some kind of demos. You can skip the install stuff, but it'll just kind of run you through some Singularity help stuff, download an image, run it, things like that. So that'll help you kind of get familiar with Singularity. We also have a user guide page for Singularity. Basically, pretty similar content that what's in this workshop. Basically, just get you up and running with Singularity, how to pull images, how to build images, and so on. Yeah. So again, also that Singularity link to Singularity Remote Builder here. And another thing to note, you might find discipline-specific container repositories out there. So if you're doing bioinformatics, there is this pretty cool repository out there called biocontainers, and basically they just have a bunch of ready-to-use containers out there. So if you go to biocontainers.pro, click on registry, you can, similar to the Singularity library, you can just kind of search through, try to identify, see if there's like a pre-existing container image out there that you can use. I'm not super familiar with bioinformatics, but there's a lot of stuff here. I think something like SAM tools, for example. I think there's like an RSAM tools one. Yeah, so there's a bioconductor SAM tool. So if you find a container, basically you'll have some usage information here. So in this case, this is a container. This container contains the bioconductor version of our SAM tools package. And at the bottom here, you'll see Docker, but you also see a Singularity installation. So in this case, we can just copy and paste this, super easy. Go back to our terminal, just copy and paste. In this case, basically, it's going to download it. This one looks like it's a little bit bigger, so it's taking a little bit longer to download it. I guess it's using the Singularity run command. So I'm not sure what it's going to run here. Okay, I guess it opens the shell. So if we look at, let's see it's in the file system, I guess. So I guess there's a setup a little bit different. Pretty similar. But okay, so this was an R package, right? So we do which R version. Looks like they got the R 4.0.3. So if we start up an interactive session of R, if we do the library function, we can see what packages are installed. So I guess the main one here would have been our SAM tools in this case. And I guess all the others are basically dependencies. Yeah, so we got our SAM tools there. So yeah. So I don't know if you wanted to, I guess if you just load our SAM tools, start loading stuff. And then there you go. So again, so that can be super useful. So I know our SAM tools can be difficult to install sometimes. I know a lot of bioconductor packages can be difficult to install. So sometimes if you can identify some of these container images that already exist, as you saw right there, right? So I'm up and running in like 5 minutes, right? So that's a lot easier than trying to, navigate all these software dependencies. Sometimes using the native software modules. But again, it just kind of depends if that pre-existing container image exists out there. So if we want to exit whoops, this is still inside our again, you just hit exit. So yeah, so there might be other container repositories out there. This is the only kind of discipline specific one I know, but there might be other ones out there. But yeah, so I guess that's pretty much the end of the workshop. So does anyone have any questions? Feel free to type in the chat there. Any points of clarification? Any other examples that you might want to see? And so yeah, so one thing I noted earlier, so we do have the current version of Singularity is 3.6.1. I think the actual latest version is 3.7.2, I think. So we might update the version of Singularity from time to time. Typically that'll be on the maintenance day. So, oh, question. So can I install other packages in the rsamtools container? So no, actually that's, you won't be able to install stuff inside of it. So again, that goes back to the idea of the containers kind of being like unchangeable. Like once you've created it, you want it to be self-contained, right? So you want it to be kind of reproducible and self-contained. And so you don't want to create it and then sort of add stuff into it. So I think if we tried, I think it would basically error out. So if we tried to install, say, data table, whoops, quotation marks. Oh, well, in this case, so this is where I mentioned, sometimes bind mounting directories can do weird things. So in this case, I actually have, I set up my R packages to install my Scratch directory, and I automatically bind mount my Scratch directory. So in this case, it wanted to install it into my Scratch directory, but in this case, I got an error because of the compatibility issues. So that's what I mean. Sometimes you have to be careful, but in any case, basically it'll error out. You won't be able to install stuff. It'll error out. So yeah. So if you did identify like a container image that basically has most of what you want, and you just want to add on to it, you can go back to that remote builder, and you can start with that container and then build on top of it. And one thing to note about R, there's this project called Rocker, which is basically a set of pre-existing Docker images. So if you go to Docker Hub, search for Rocker. Basically what the Rocker project sets up is kind of different levels of R. So basically they have kind of like R base. Then they have tidyverse, which is R plus tidyverse. They install tidyverse packages and so on. And there's like a geospatial one and that kind of stuff. So I guess we can try this real quick. So if we go to the R base one, so if we go Rocker R base, if we go back to the Singularity remote builder, let's see, remote builder. So if we started our definition file, the header, in this case, if we want to start from Docker instead of library, let me do from, let me do Rocker, and then I guess I copied it, Rocker dash R base. So let's say we want to start with that container image. So basically that container image has R's already installed in it. In this case, I think it's probably the latest version of R, which I think will probably be 4.04, I think. Then if we add that post command, I'm not sure if this works, but let's try it. If we wanted to install R packages, Let's see. I guess we have to use R script -e. And then let's say we wanted to install, I don't know, the reader, nothing too intense, or the reader package. And let's just keep it simple. That's basically that's all we'll include there. So we check, okay, it says valid definition file. Let's see if this will work. So click on build. So let's see what happens. So first, since it's starting with Docker, it's going to convert it. It's going to convert that base Docker image first. First, it's going to convert it to Singularity, and then it's going to run that post command. So it looks like it's working. I guess that reader's got a bunch of dependencies, so it's going to install those. So we'll see what happens. It might take a minute here. So okay, looks good so far. Still running. Okay, so. And so again, depending on how complex how much stuff you're installing, it might take a little while. So you might go and do other stuff and then come back and check the log file. So it shouldn't take too much longer. So okay, still installing. I probably should have installed data table because that doesn't have many dependencies. So I think I might have, once I get this up and running, assuming it builds successfully. So I mentioned I had set up my environment variables for Singularity. So if I check those, so I automatically bind mounted my Scratch directory there. I think I want to get rid of that just in case that causes problems with this R, this new R container that we'll download here. So if I do, I can unset this. Okay. So now that I've gotten rid of that environment variable, it won't automatically bind mount my Scratch directory. So okay, still installing. Okay, now it's going. Okay, that's good. Installed successfully, and now it's just finishing up, creating that container image. I think sometimes I'm not sure if there's actually a success message down here. Sometimes you have to scroll back up. I guess we'll find out. And again, this is something, if you don't want to use the web interface, you could also use that Singularity remote command, Singularity build -- remote, if you wanted to create your definition files on the CARC systems and then just build it remotely. You can also do that. So should be done here any second, I guess. There we go. Okay, yeah, it pops up here with this little green pop-up, build successfully. So cool, okay, that's what we want. Now let's go download this container. Let's see, go back to my containers. So now I've got 3 images. I guess it's this one. I could be wrong. Let's see. It says 144. It's not 144. Here, this one, I guess, 232. Okay. And you might be able to, I guess you might be able to actually label these in the web interface. But in any case, so if we download this one, just give it a name. I'll just do, let's just say reader.srf. Whoops, space. So, okay, this one a little bit bigger, 315 megabytes. Okay, so let's just verify this. So, okay, Singularity shell, the name of the file. So startup R. Okay, so yeah, I guess R version 4.0.5 came out, so that's the latest one. And then I guess, yeah, just use that library function again. So yeah, it looks like a reader. Oops. It's in there somewhere. Yeah, there it is up there. Okay. So let's just try loading it. Should load fine. Yeah. So yeah, that was cool. That worked. That worked fine. So yeah, so if you basically, the example there, basically if you find a container image that maybe there's like a base one out there that you just need to modify 1 or 2 things, you can kind of set it up like that. So I think you might be able to access the actual definition file that you used. At least you used to be able to. Well, in any case, so basically, yeah, instead of in the header of your definition file, right? Basically, instead of that, you would just give it the bootstrap. You just tell it which container image you kind of want to start from. So that's basically the basic setup for doing that. Okay, yeah. So, any more questions? Any more examples that you might want to look at? So if you want to reference, so these slides are available on the web. I'll just put these in the chat here. So I'll probably make some changes to these. I might make some updates to these. I might make some updates to the Singularity docs page soon as well. But if you have any questions about building Singularity container images, using images, running them, feel free to submit a support ticket. We'll help you with that. And another thing we might do in the future is we might set up some kind of pre-existing container images, maybe in like a special project directory. So maybe if there's popular containers out there that a lot of people are using, we can just set that up automatically so you don't even have to download stuff. You can just access a project directory, like a special project directory that we could set up. So if there's any interest in that kind of thing, also, get in touch, send a support ticket. If there's any interest in that, we could set that up. Another thing I'll try to do is maybe try to set up some example definition files. And I can share those. We also have this GitHub page for the workshop, GitHub repo. So I might upload some GitHub, some example definition files to that as well. So yeah, so if there's no other questions, go ahead and sign off. Thanks for attending. Again, if you have any feedback, any questions, feel free to submit a help ticket and we'll get back to you. All right. Thanks, everyone. Have a great weekend. All right. See ya.